Domain, all that business. I watched my time here. I'm doing such a beautiful job. Now, that's how you want to close it down. Looks like we're almost there. So I'm going to start that chapter 5 after the break. Do just a few things to chapter 5 though. But first, here we go. Part 5, part 6. And by the way, I appreciate this. If you travel over to UCLA, my student from UCLA is coming in on Monday to talk to you guys. They have questions for him. When you go to a major university, I've taught one, you're not going to get this. You're not going to get this. You know what I did on Monday? That's done. If you're at UCLA, I'd be doing the first 3 sections of chapter 5 right now. I would not be, they do not recap. You go to Mr. Park, it's called a teaching assistant, you go to the TA on campus, and he or she, if you have questions, they will repeat, not the professor. No, that's not how they finish those chapters so fast. They do not go back. I can't do that myself. I've got to go back and sort of put everything together before I close it down. So the last thing here I want to do to close it down is we go do one sketch, a graph. And guys, it's a function, f of x is equal to, this is beautiful, negative log base 4, x subtract 2, subtract 3. That's the way I'm closing that chapter 4. Yeah. And I should say on the side here, use transformations. Okay. Now one of my students has just confided in me, told me that at his work site, that his employer, I guess, some people who work there, asked him that he's a little bit different now at work, right? A little too busy or something. And you remember that little thing I told you guys the first thing I mentioned? If you have a girlfriend, boyfriend, employer, mom, dad, some of us may have children, you want to let them know you may not be around so much. You met someone. And he had to tell his employer. Hey, don't put you on the spot. Is that true?
Yeah.
And what'd you tell him?
Told him you need to take off.
You need to take off some time. And besides that, who'd you meet?
Professor Ramsey.
Oh, and the best one I thought when he told me this, one of my former students came in and told me the same story. And when he went to his boss and said, oh, and the boss said, oh, I think you seem like you're going to the back there and doing some homework or something. You're staying busy, aren't you? And this is a former student. The student said, told him like, hey, I'm doing math 2. And this is where at SMC? Yeah, math 2. Oh, let's keep you busy? Yeah, who you had for professor over there? Ramsey? And guess who taught the employer?
Did he say I'm sorry?
Now you told us something. Yeah, his employer is quite, may not be quite the employer, but he's the head of that department. I told him. He said, you have Ramsey too? Oh, good luck. Get all this work done. Okay, guys, here we go. Guys, start me out. That I'll do in red. Reflection. Reflection through the x-axis. X subtract 2, thank goodness it's written in a fairly good form. That says there's going to be a horizontal shift. Black. Horizontal shift to the right, 2. Hang on until I get this. 2. And then we got -3 hanging on. One of my markers is messed up on this, I can look here. Now try blue. Vertical shift down 3. Don't you guys leave class and get outside there and start working somewhere. Think, all of a sudden you may run into someone, you had Ramsey? Yeah, I had him too. The last flight I took out to Las Vegas, I didn't realize one of my students was a flight attendant. One of my former students. I didn't see her on the plane itself. She was in a different section. And all of a sudden we started getting off the plane and she was there to say goodbye. Ramsey? I thought, oh my goodness. You didn't do that well in math too, but you're a flight attendant. Okay. Yeah, she was good. Okay, here we go, guys. Here we go. First thing, a parent graph. Now, this is a log.
Yeah.
And I know and you know what a basic log graph looks like. I hope. You have an x-intercept at 1, and it looks something like that. So this is y is equal to, I will label log base 4 in this case, x. That's my parent graph. Now start applying the transformations. The red one says, please reflect that through the x-axis. Don't let me mess up on this to close down. Does that mean now this? That's right, this is y is equal to, keep straight here, negative sign out front. That. This takes way back transformations. Now take the red, and if I go right across here, it says now horizontally shift that to the, oh here, in the black, horizontally shift that, 2 to the right. And here goes. So I gotta shift the red graph 2 to the right. I've gotta be careful myself. Please guys tell me, on the red graph, I do see it's at 1 right now, the red graph itself. I shift just that 2 to the right. That's gonna take me down here to 3. Now, can someone tell me something else I better be careful as I start shifting? That I better be careful there's something else I've got to shift along with this.
Asymptote.
The asymptote. That vertical asymptote is also going to be shifted down 2 to the right, so now it's down here. This is my y-axis. That's this. It's also being shifted down 2 to the right. So this point right here is being shifted down to 3, 2 to the right. And my vertical asymptote, the y-axis, is also being shifted down 2, so 0 down to 2. Got that? Guys, with that much right there, let's do this, I guess, in black. I would accept. It looks something like the red. That's down there now. It's to the right. Yes, no. Now, last one. The blue. Don't stop there. Now take the black, do what? Shift it down 3. We're closing down class. Take a break here. We're going to shift it down 3. We'll mark that. Get ready for it. Woo! I know for sure at that point there, I know the location of it, if I shift it down 3, vertical shift down 3. It for the blue, I know it for sure. It's down here at -3. Would you guys agree?
Yeah.
That one's for sure. Now take the black down 3. Can anyone tell me what I always ask you to do when we did transformation problems on that last graph? Yes.
Do you have a limit?
No, something else.
Domain?
Back on a quiz or exam that I've given you on transformations, which we've had, I said something I always ask you to do to refine the graph, find something right at the end before you finish the graph up.
X and Y or something?
The x and y intercept. So on the side here, I need to find, finish this up, this. Now the x-intercept may be harder to find, but this is where we find it. You take your function and you set it equal to 0. That's probably the toughest part of this problem. But you gotta solve it to find the x-intercept. I would suggest you maybe move the 3 over. You guys also might suggest something else I could do first. Does anyone see anything else I could do first besides just moving the 3 over and then doing something else?
Divide by -1.
I could divide everything by negative, change those signs, which might be better. Thank you. And write this as log base 4, this, plus 3 equal to 0. Oh, that's nice. Just got rid of those negatives. Now move the 3 over. Now here's where it might get you. Be careful. Now, can someone in this clever class and close it down? Before I can solve for x, you gotta tell me. I say, hang on up real quick. I love that. You gotta tell me what that means. Yeah.
4 to the negative third power equals x minus 2.
There's a
That's
math-
gonna be
There's a mathematician right there.
1 over 12.
No, no, but
Oh, and never mind, 1 over 4 is the
4 times 4 times 4.
64.
64.
1 over 64.
1 over 64.
Yeah.
Now, you're talking about clever, that's being clever to recognize that she did it. Now to solve the guys, all I need to do is move the 2 over. I'll write it as 2 and 1 over 64. That's my x-intercept. So I move the 2 over. Done. Y-intercept, how do we always find a y-intercept? You replace x by 0. You find f of 0. That might be one. Let's see. Negative log base 4, 0 subtract 2, subtract 3. I replace this x with 0. Is there an issue?
It would be negative.
There's going to be a negative inside there,
Yeah.
and I can't deal with it because of this back here. Can't deal with it.
Give like.
It takes back to the definition. So this is out. There's none. No y-intercept, we have an x. Now we put that 2 and 1 over 64. That's a strange number. Just a little bit to the right of 2. It's right here. 2 and 1 over 64 is close to 2. Now is that enough to plot and get the last graph? Yeah, it's gonna look something like the black graph, but it's doing this. Go down, it's gonna pick that up, go down. It's gonna look something like that, does not touch that asymptote. And that has the same shape at least of the black one over there. Is that true, guys? And that was my x-intercept at that strange number 2 and 1 over 64, is that true?
Yeah.
That's gonna look something like that, and that blue is my final graph. Yeah.
Does the base of the log matter in the graph?
Ah, beautiful, beautiful, right here. Right here. I would say no right now.
Okay.
Okay. Until you do, let's see if we had to do it here. Now we had to do this, that matters here. Well, I take 4 raised to a -3, that matters on that x-intercept. Yeah. So guys, you agree with the graph? Now, I see it, we'll close down. Well, this is chapter 4 completely closed down. Can anyone look at that final graph? I have it in blue. Look at the, oh, I got tons of questions, at least I sure do, but first, I'm gonna ask a few. Can anyone tell me the domain on that blue graph? Yes.
Parentheses 2 to infinity.
Look at that, hang on now, hang on now, hang on. Mathematician. Now, could you have told me the domain back in the original black function up here, before you saw the graph? What would you say the domain was there? You say, Professor, you already said this has to be what? Greater than 0. Definition. Then solve for x, and you're going to end up with what? X is greater than, let me write this down here, subtract 2. Is x greater than 2, even if you thought of it like that? Does that agree with her answer there?
Yeah.
Absolutely. So the graph tells me. Now how about the range? The up and down? Yeah, negative infinity through positive infinity. The range, the up and down that blue graph. Wow. Now, I'm looking at here, I think we're finished. Now, those of us, and I realize you're saying, Professor, my goodness, we covered some sections so fast. That's one reason I took all this time today, to try to put it all together. It's all, I keep on going back to that right there. So many connections. Okay, great. We okay now?
Yes.
I have just one concern. So for 1/64 equals to x minus 2, are we 1/64 have to subtract 2 to get the x?
Oh, that's, you mean right here, I got you, right here. When you, trying to find here, we move that 2 over?
Yeah,
All you're saying, Lisa, is this.
yeah.
I just called it that.
I didn't saw the signs.
Or you can put these two together with common denominator of 64.
That would be like
And then divide out and see what number you get.
6.
Put 2 and 1/64.
128.
That's your x intercept. 129 over 64.
129/64, okay.
Yeah, you good right like that?
Mhm.
You guys need a break, don't you?
Yeah.
We've done all of chapter 4 in one, session.
Yay.
Wow.
But look, we had done parts of this already. This all came together. Okay, guys, well deserved.
Thank you,
Great.
Professor.